For this video, I'm going to introduce an example that I'm calling SpiderSac. I think it's a pretty good paradigmatic example of what kind of new tools can be created and thus what kind of new forms or new processes you can work with. One obvious thing that you could notice is that on the left-hand side, you have this model view or this kind of interface view where I have these blue balls that create a solid form and these pink balls that create a negative form. And on the right, you see a very different view that's a form and a shape and a structure and some information, some coloring, and also the backdrop of the city where you can't see these interfaces or these points of interface. So this is a kind of an interesting way to split design and representation but have them be synced, and obviously as I'm moving the mouse around, the views are coordinated. And this is one of the ways that I'm positing that as you make it, you see the results and you see the analysis, and this is how this is part of the crucial aspects of the tool, that you do have this feedback loop between doing something and then knowing what you're doing. The other aspect to note here is that there's a panel over here that determines the floor height. So as I move that around, the floors change, and I can move the thickness and the floors change also. So you notice that I'm not even going to Grasshopper. I'm just working in Rhino. And the other aspect of this interface form is that as long as I'm on the right layer, I can start creating new points, and the model will modify to adapt to that point. Again, normally it's very zappy. I think the screen recording software I'm using is a little lag or draining my resources a little bit. This also means that I can delete a lot of points and have the model change immediately. And just to show you a little bit more about how smoother it can become, I'm going to make the model a little simpler, so that this means that if I change a lot of points, say I rotate all these points, the resulting model, there's a drastic change in what the model is. And so this as like a prototyping process is invaluable, because I can start to add new points, delete points without having to go into Grasshopper or select anything. It starts to just become about what points you press, what forms create, and that's kind of the best example of a tool I can give, in that in the design process, I'm not thinking about Grasshopper, I'm just deleting these points, and you see what's going on. I can see an effect, or see the model change. So the Grasshopper code is here, and I will actually start this from scratch. But the long and short of it is that I'm grabbing points. I'm grabbing both the positive and negative points. That is to say, I'm grabbing points on a layer that I've deemed positive and negative. And with the positive points, I'm creating a positive volume. With the negative points, I'm creating a negative volume. I'm bullying them out from each other and creating a void. It looks like the void's not quite intersecting here. Okay, so I'm going to start with the kind of base template of any given tool. So one thing we need to do is we need to create a kind of left and right view. We need to have them synced together. And I'm going to do that with this tool I'm calling Flounder Camera Control. It's a tool I've made, and basically it has three inputs. You give it an activation Boolean toggle, a source viewport name, and a destination viewport name. You can find this by Googling Flounder Camera Control, flounder like the fish. It's probably the first result. You can go there, download the camera control tool. Be sure to download version number 2. And when it's done, you can open the archive and drag them into the Grasshopper window, and they should be installed. In my case, I've already installed them, so you're getting this message. A new tab should appear, and you can drag them onto the viewport. Now the next thing you need to do is to actually create the two views on the left and right hand side. So what I'm going to do is I'm going to set both of these views to a perspective view, and I'm also going to actually reduce the number of viewports. I'm going to close this viewport, close this viewport, close this viewport, and I'm going to expand it so that what you see, so that you only have two viewports. You don't necessarily have to do this. You can imagine having multiple, but I'm just doing this for clarity's sake. And then I'm going to name the viewport on the left-hand side model viewport, or interface viewport actually. And then I'm going to call the viewport on the right-hand side the interface viewport. Or, sorry, the model viewport. So you can see that where this is going if I take the sync flounder camera component, and if I add a toggle to here, and then I add a source viewport name that's called interface viewport. Do the same thing for here. What it's doing is it'll take the camera of this viewport and sync it to this one. Great. Now I'll toggle this to true, and it's synced, you can notice, but it doesn't continue to sync. Now this is because I don't have this component was activated once, and if I untoggle it and toggle it again, you notice that the right hand side, the model viewpoint, was changed also. Now what we really want this to do is we want this to kind of constantly be running in the background. So I'm going to use the timer component and plug this into here. I know earlier I think I typed interface viewport. This is a little shorthand. If you double click and into the search bar, you can type quotation mark and actually type the text you're using, press enter, and you'll get a panel with the text pre-entered in it. If you double click and press the quotation mark and just click on panel, you'll just get the a panel. So back to the timer. Again, I've taken the timer and I've clicked on the red arrow and dragged it to the component. And this means that this component will be triggered every 1 second. I can right click on it, set the interval to 50 milliseconds, say, and that means that as I'm moving this, the panel moves and tracks and follows my movement every 50 seconds. I can set it to 20, it might be a little smoother. Also I notice, I think the reason why it's a little jittery is because my camera recording software is slowing a lot of things down. So now we have this left and right viewport, and we can also, the fun thing about this is we can have the left viewport and the right viewport have different display modes. Let's try, whoop. So if I create a box, you can, this is really helpful because the model viewport kind of presents it in an interesting or a more polished view, and then you can have the interface viewport be for editing. So that's that, and I'm actually going to highlight all of this, and I'll turn this off to false and turn the timer off so that it's not constantly running. So that's the part of my patch or my component that deals with the control of the camera. Now, what I want to do is I want to create a bunch of points, or I want a component that creates a bunch of points, let's say, and automatically creates a volume around them. That's an ideal. The problem with Grasshopper sometimes is that if you want to use a bunch of points, you have to open Grasshopper, get a geometry object, right-click on it, select multiple geometries, and then if you add another point in the future, you would have to select everything again, right-click on geometry again, set multiple geometries again. Now, in order to not do this, there is a component called the geometry pipeline. And the great thing about this component is that it grabs objects based on their layer, the object name. Every object in Grasshopper technically has a name, even though you normally don't use it, and then the type of object. So I'm going to open the layer tab in Rhino by typing layer, and I'm going to set one layer as positive points and another layer as negative points. I'm going to highlight all of these points and put them into the positive points layer, and I'm also going to set it so that we're on this layer. So that means I'm going to close this out again. So if I double click on this geometry pipeline object, I can edit this and I can say positive points. Make sure that there's not a space. Click star. And then I'm also going to ask it to choose points. So I'm going to double click on the points. So only grab all the points on the positive points layer. And then if I feed this into geometry, then you'll notice that if I open a panel object, I have grabbed those referenced points. Now if I add a point, you can notice that the points just start being added to the list. So the geometry pipeline is automatically grabbing the points and letting Grasshopper deal with that. And this is incredibly handy, again, because this means that I can create an interface without thinking about Grasshopper going back into Grasshopper. So I want to create a positive mesh around these points. And how may I do that? Now, one option is I could go into mesh and use a convex hull kind of option. But the problem with that is it's in 2D, or I can use the Delaunay mesh one, but it's kind of not what I want. Actually, this tool is best done by a Grasshopper plugin called Starling. And if you Google Starling and Grasshopper, you'll get this component within Food for Rhino that you can download. This is actually, it's a part of a process called convex hull. And if you Google convex hull, you'll find these forms, which is basically the smallest form, convex kind of polygonal, 3D polygonal form that includes all of these points. I think this is a pretty good example of what you're talking about. So if you Google convex hull Grasshopper, you'll find Starling Grasshopper. And that's how you can, how I found this plugin. So download Starling version 0.2 and install it like you did Flounder, and then you should have a panel up here. I'll actually just walk you through the step of downloading it, since this is a tutorial. And if you download it, you'll notice I've got Starling 0.2.gha. You can probably just drag this over into the panel. Since I already have it, it asks me if I want to replace it. I say yes, but if you won't have it, you'll just notice that a tab pops up on the top. If you click on the Starling tab, you'll see all these different kind of options. Now what I'm going to use is I'm going to use the SL, Starling Hull 3D, which is incremental 3D convex hull. So if I take this, I'm going to delete these guys. Notice that it takes as an input the points. So if I give it the points, it gives me a hull, which is absolutely amazing and very convenient. And it's very fast too. So this is kind of exactly what we want. And just so that we understand what we're seeing out of this hull, I am going to grab the edges. Actually, I don't think this does it. And with mesh, I'm going to go to mesh analysis. I'm going to ask for mesh edges. So 3D hull gives us the mesh. I'm going to plug this into mesh edges. Now you can see the meshes, or the edges of the mesh that we're dealing with. If I move these points, the mesh changes. And also, since we have this going on the geometry pipeline, if I create new points, the mesh automatically changes, and if I delete points, the mesh changes as well. So now, you can imagine that I can start playing around with this interface without having to go into Grasshopper, and without doing things like editing the points of a mesh manually in Rhino, etc. And arguably this mesh is parameterized, right? You were working with parameters that were constantly changing, so it's very convenient. Now let's say we also want to have negative points, because this isn't enough. We also want to carve negative volumes out of these things. So let's do the same thing with the geometry pipeline. I'm going to call negative points. Call this layer called negative points, and remember that before we created a layer called negative points. So I'm going to set my layer to that, my active layer to that one, and start making a series of points. Notice that the geometry pipeline is grabbing all these points, and I'm going to do the same thing. I'm going to put them in a geometry object, put them again in the 3D hull through the 3D Hull component in styling again, and here. And then just for kicks, I'll also let myself see the edges. So I want to use the negative points to create a negative volume, so I'm going to subtract one from the other, which is done in intersect. You can go into shape, and because we're dealing with meshes, it's mesh difference, right? I can also type diff again. And since this is our mesh, I'm going to subtract B from A, or use A and subtract B from it. Then I get this volume. And I'm going to hide, actually, the two original hulls. And if I click on this, this is what I get, which is pretty interesting. Let me try to make more mesh points so that, okay, so this is a little bit better visualized, perhaps. It's a little unclear what's going on. Let's move things around a bit just so that we have a good example that we can work with. One thing you can also do in Grasshopper, if you don't know, is this tool is very helpful. Only draw the preview geometry. So this is our positive volume. Oh, I see. It's not that volumetric, in fact, which is perhaps part of the reason why. We're not seeing very much. This is our negative volume. So then if we do the difference, and actually let's use the edges on this difference also, perhaps we should see something interesting. Interesting. Let's actually try the other way around just for kicks. Ah, so in this case it works. You're seeing the subtraction. Okay, so let's go on forward with this, and as actually this is probably a good example. As you go on, you'll notice that sometimes it's hard to see what's going on, and the reason why I added edges is that so I can get a spatial sense of what's going on. It will often be the case that representation actually gives you a better idea of what you have to work with, and thus lets you design more effectively. And so in tune with that, I'm going to create little balls around these points, because part of the problem with these points is that I don't have a good enough sense of depth, because the points are the same size no matter what. So to kind of create a mock-up of the interface, I'm going to grab this geometry and move it over here. And I'm going to create spheres around each of the points. And it looks like it's too small to see them, so I'm going to alter the radius of the spheres, put them on a slider. Here we go. So now they're much more visible. And you can see that if you zoomed, you can, to some extent, and I'm also going to change the perspective with dolly zoom. To some extent, you can see that this point is closer than that point, and use that to modify your geometry a little bit. You can already tell that, at least for me, I can feel that it helps a lot. Right? You know, it alters the kind of design possibilities that we're seeing. There we go. Right, and the balls help a lot. They help a great deal into getting a sense of space. So that's great. So I have these spheres, and I'm going to jump ahead actually and to represent them, because right now there's this like blocky reddish thing and everything's the same color, and I'm going to use the custom preview item to change the color of how they're displayed. So I'm going to click color picker, and the preview item takes geometry and takes a color object or a shader object or a shader value. So I can plug this into here, and it's taking the geometry of the sphere and the color of the shader, and then I can change these points. Now what are these points? These are the positive points, so let's have the positive points be a shade of neon blue or green. And we can do the same thing to the negative points, and let's have the negative points be a shade of fuchsia or maybe neon pink. So that's a great help in that now I can see which points are which. Maybe these points are too big or too small. And I can move these points around, you know. I can grab this point so I can tell it's a negative point. And in the process of doing so, I'll alter my geometry. Now the other good practice to do is to kind of clean up my stuff. So I'm using these components to previews, which means that I can take these components, which are creating the geometry, and hide them. So I'll middle click, go to hide. So we've hidden that geometry. And let's say I also want to represent the holes as well, but I actually don't want to represent the full geometric hole. I only want to show the difference. So I'm going to delete these guys, and I want to represent this hole and its edges. And I'm going to copy and paste this preview object and its shader, and I'm going to plug this into here. So now I also get a mesh-based kind of solid color or solid object. And yeah, for kicks, let's make it this orange. I can also change the transparency of it down here with the alpha value. So you can imagine that this is kind of like the ghosted view in Rhino. You know, you can, depending on what you want, it might be helpful to see through the mesh. In my case, I think it kind of is. So great. And the same thing with the geometry. I'm going to color the geometry and have it be a different color. Sorry, but the wires of the mesh. And technically, the mesh edges divides the kind of edges of the mesh into different types of edges, depending on whether one edge is adjacent to one face of the mesh or whether it's adjacent to 2 or 3. But we just want all of the edges. So I'm just going to hold shift and plug them into here. Actually, we don't want this line. So I'm going to right click, disconnect this component. You can see it being highlighted. And then as for the mesh edges, maybe I want them to be solid white. Okay, so now I've created this representation. I've kind of adjusted the colors of representation, and already you can see it kind of looks like an interface. Or what I've been creating with Grasshopper, it already seems to exist as an object in space, which I think is a very important thing when you're dealing with these tools. You want to have them give off the impression that they're not just provisional things, but actually real objects. And again, like I said, I'm going to clean up my geometry by hiding all the objects that are not being... I'm going to hide all the previous geometry that isn't being piped into the preview objects, because I want to have control over how my final component looks or my interface looks. I might even grab these and hide them. And note that hiding is different from disabling them. This is disable, enable. Disabling will stop them functioning entirely, but I can enable them and then hide them. So this is pretty great. And now I have this hull. So, and depending on what I can do with these things, I can move these around, change the shape of the hull. Let's say I actually do want to see what the pink geometry is being created, or the pink balls, the negative geometry, negative points are creating, and what geometry the positive points are being created. So I am also going to represent these holes, which I'm going to click on this button to only draw the preview geometry for the selected objects. And I can see that this is creating these points. These points are creating this geometry. These points are creating this geometry, and I want to actually represent that because it might, I don't know exactly what this point is doing. That's another aspect of the tool. If I move this around, it's doing something. How do I know it's doing something, and how can I, what does that mean to me? So going to take another preview object. And then I'm going to plug the hole into here, into the geometry of it. And I'm going to make the hole color a bluish color since my points are bluish. Somehow that seems to make sense. And then I'm going to, I can make it fully solid, but I'm going to make it semi-transparent. I'm going to do the same thing for the negative points as well. Grab the negative hole, plug it into here, make it slightly reddish. So then all of a sudden you see these two forms, which is incredibly helpful. Now the downside to this is that there's a lot of stuff going on here and I'm not sure what I'm really doing. And this is why these two views come in handy. I can show something here and represent something here and they can be separate, which means that to some extent the interface or the inputs or my controls can be separate from the result. But since I'm seeing them at the same time and since they're again being synced and coordinated, I can have this feedback loop of design because I'm looking at the results of my design. So Preview has this great function that I can right click on that it's called a viewport filter. It means that it will appear only in the viewport that matches the text. So if I type in interface viewport, you will notice that it disappears from here and only appears in here. I can do the same thing for this viewport, this preview object, interface viewport. Right, and press enter. Interface viewport, enter, and it disappears in here, appears in here. Now I'm going to actually hide the final geometry in the interface and only see it in the model. So I'm going to right click on this preview object and type model viewport. So now you can see that this is pretty interesting. I'm seeing the positive and negative forms on the left hand side, but only the final geometry on the right hand side. And right now I'm actually going to turn the camera sync tool back on because I think it'll be helpful to understand what's going on more. The other thing I want to hide in the interface are these white lines, since the white lines only correspond to the final geometry. So I'm going to right click on this and type in model viewport. So this is pretty convenient, but you know, I probably want the lines on this side too for the lines of the edges of the mesh. So I'm actually going to copy this over and have this correspond or work with the meshes of my my positive and negative hulls. So I'm going to drag the hull geometry into the edges, which means I grab all these edges, and then I'm going to represent this, but only in the interface viewport. If I undo this, see the lines are only on the left hand side, and I'm going to make them like a darkish blue perhaps. And I'm going to do the same thing with the negative negative volume. I want to see the edges of it because that gives me a really good sense of the depth and the geometry. It looks like it's hidden. Let me do that again. Actually, so then notice that as I change this color, the lines on the left hand side change as well. And okay, so and let's also say that these these spheres for me are, since I wanted them to give me a sense of scale and depth, I don't actually need them in the model viewport or the final viewport. So I'm going to take these balls and say, okay, only show them in the interface viewport. Great, so now we have an example where we have this form, we have this volume, we have an interface on the left-hand side. We're showing the positive and negative side forms that are being created, and we see the output on the right-hand side. You can grab some geometry, I can rotate it, I can add a new point in a specific layer. You know, I can start like carving away at this thing. Maybe this looks structurally impossible, so I'd start deleting some points, or start moving some points around, etc., etc. Which is already kind of an interesting thing, and these forms are not so easily modelable in Rhino. You know, I can model this for sure, but I can't approximate this so easily and so immediately. Now the last thing I want to show you, and before I do that, I'm going to take all these preview objects, I'm going to group them and set them aside. The last thing I want to do is, I also want to do some analysis, because I think the important part of the tool is knowing what it does and what it doesn't do. And maybe, you know, I can create form with this, but I think it's also interesting when the tool also tells you information about the form that you can't just see. So one thing I'm going to do, which is in some ways the most straightforward of processes, is to slice it into floors, and then to calculate the area of each floor. Looks like this is the difference. This is the Boolean difference. This is where this happens. So I'm actually going to take this and remove this from a group, ungroup. So now I have this mesh. What I want to do is I want to take the mesh and I want to slice it. Now, this can be done by the contour command. Contour. Create a set of BRepper mesh contours. I'm going to take this contour object. It takes the actual BRepper mesh. It takes the start point of the contour, the normal direction, and the distance between contours. Now the start point is a little tricky. How do you know where to start? We want to start at the bottommost point and go all the way up. Now if you think about it, the bottommost point is, you can grab this many ways. There are several ways to do it. One way would be to say, okay, I want to get the bounding box of this object. So I'll plug it in here and I grab this bounding box, and then I'm going to get the corner points of all the objects and find the point with the lowest C value. That's entirely possible. There's another way to do it, which is if you thought about it, you would say, oh, since my positive volume is derived from these blue points, I just need to get the blue point that is the lowest. Right now, let's try the bounding box point of view, because it's probably, you can use it in many other situations. So again, I grab the bounding box object, and it gives me this box. Now what I want to do after that is I could get the box corners, and I also get the construct box, which if I plug the box into it, you want the first box because you want them to be in the coordinates of the world, not the local coordinates of the plane that the box is oriented on. You can see that this gives you the plane, the x dimension, the y dimension, and the z dimension. And the z dimension, it gives you 0.0 to 160. It's a domain, which is like a range of values from this to that. And because we're just contouring out, the x, y of points don't really matter. All we need to know is the lowest most point. So for example, if I move a whole bunch of geometry downwards, and I look at the C value, it'll tell me negative 38.006. That's just the value we want. So I'm going to go into set, into domain, and go to deconstruct domain. So a domain is from negative 38 to 122. If I plug it in here, it'll give me negative 28, negative 38, and 122. Now from this I can create a point, construct point, and I say I want my z value to be negative 38, and my x and y values to be 0. So here I have my lowest point. So I can grab this and plug this into here because it wants me to grab the start point. Now one other thing, this is kind of a momentary parenthesis. I have all this stuff, and if you think about it and talk about it in terms, what this does is it grabs a geometry and finds out what its lowest point is, or the lowest point in both just in terms of a z value. And Grasshopper has this function called clusters, which I can middle click on it, and I can go to this object which says convert all selected objects into a cluster. Now if you think about it, this component takes something as an input and spits out an output, and whatever is going on internally, you know that it deconstructs the domain. That's its function. Clusters are kind of similar. If again I highlight everything, I middle click on it, I click on cluster, and then it encapsulates everything into this clean cluster of chunks of information, or chunks of components, and it takes as an input the geometry and takes as an output, gives an output the point, and I can right click on it and rename it just for myself, get lowest point. And what I usually do is I actually add a hashtag at the start. This is just my personal notation, so at a glance I can tell when something is a cluster or something is like a native component in Grasshopper. Now I have this cluster, and if I double click on it, I can actually enter into it and edit it, and you notice that it's exactly what we saw beforehand. There's an input coming out from somewhere, coming in from somewhere, the outside world, and goes through this, creates a bounding box. It decomposes the box and gives you the x, y, z dimensions. From there, I deconstruct the domain of the z dimension. I create a point based on the lowest value of the z dimension, and then I send this out as an output. And if I click on this box, I click save and close, I'll enter back. That's what it's doing. And it's really convenient because I can kind of black box these very different tools into this function, and I know that whatever this is doing, it's getting the lowest point of a form. So back to the contour, we wanted to grab this form and contour it. So we have this form, we have the mesh, we have the lowest point, we have the normal direction, it's 0, 0, 1, but let's plug in, we want to go in the z direction, right? That's our contour. We wanted to have horizontal floor plane slices. And the distance between contours, we'll say, let's give it 10, or actually let's give it 15. This is a shorthand. If you double click and type 15 or any other number, it'll give you a slider that's automatically set on 15, but has a given range that you can slide within. So if I plug this in, this is pretty great. I already can see a number of floor plates happening on the left-hand side, which is wonderful. And then with these contours, what I can do is I can make them planar surfaces with this boundary surface function. And right now actually you can't see them because you're seeing all the preview geometry, but if I click on this one, now you'll see that I can examine only the floor plates. And then I can grab the area function, plug it in here, and if I open the panel to see what the areas or objects are, notice I'm getting the areas of different floors. Now down here I'm getting two values. Well, why is that? It's because on the ground floor there's 2 points at which this form touches the ground, so there's two volumes, or two areas. At the top, this little tippy top of a point has a small volume, so that's why I'm getting the volume, or sorry, the area of 0.34. And that's very convenient and helpful. Now, let's say that I want to look at these floor plates, but I want to color them based on their area. So I want the largest floor plate to be colored light or dark, or vice versa. So what I can do is I want to look at this by floor. So I'm going to add these values up by floor. And one thing what I want to do, and this gets into a little bit of an advanced area, talking about tree logic. If you don't know tree logic, by the way, you should look at the skill tree video for trees. I'm going to add each of these values together. So I'm going to open this component called mass addition, and I'm going to plug it in. And what that does is it adds them together within within this branch of a tree. So you can see this gray bar, and it says 2280, 577. That's 2857 added together. Same goes for 3985, 1161. This goes and added together. So this list added internally together, all of the objects, become this list, which is the total square footage or square or area of each floor. And that's this one. And again, I'm going to right click and simplify and make this into a simple list. What I've done is to kind of remove any redundant information. Again, this is a tree operation, and you should look at the tree video if you want to gain a lot more information about what this just was. But this basically makes it a vastly more simplified list, and I can actually use the flatten function to make it into an even simpler list. Again, you should really look at the tree video. It'd be a lot of great help to understand exactly what I did, especially since trees are kind of at the core of Grasshopper. So now I have these values, and how do you translate them into color? Well, there is this component called color RGB. It's also above in vector, color RGB, F, floating point. What it does is each color takes a value from 0 to 1, and a decimal point or floating point. And so what I want to do is I want to grab all these values and make the larger ones 1 and the smaller ones 0. So there's a very convenient tool that we can use called remap numbers, and what it does is it takes a bunch of values, and it wants a source domain, so like what to what are we looking from, and it maps it to a target domain. What to what should we map it to? So the source domain is actually something like 0 to 7,000, 8,000. There's also a very convenient component called bounds, which takes a bunch of values, the numbers, and then gives you a domain. So whatever these numbers are, it looks at the min and max and says, okay, this is from 0.34 to 8,065. So then I'll plug that into our source domain. So what is this doing is it's taking the list of numbers, understanding that it comes from a source domain, and mapping it onto a target domain. So if I look at the remapped numbers, you'll notice that these are all conveniently between 0 and 1. And again, why are we doing this? We're doing this because we have the floor plates, we've gotten the area of each floor. We're going to map them from 0 to 1 so that we know in proportion how large the areas are. And then we're going to connect this value and make a color out of it. So then the color is right now, so again, the floors with the larger square footage are going to have, say, 0.9, and that's going to be 0.9 red, 0.9 green, or mostly red, mostly green, and 0 blue. And just to see what that looks like, let's preview the specific floors with these things. I'm going to use the preview component. They're going to plug the color into this preview component, and I'm going to plug the planes into this preview component, but this won't be kind of right. It'll be, in fact, a little messy. I'm actually going to hide this thing. Okay, great, because this geometry, the positive geometry, was getting in the way. So what's going on here? Something weird is going on. This is because, again, it's a tree-based problem. I have two things down here. Two surfaces on the ground floor. So this is what my geometry looks like. But I'm giving it this color. So it's a little confusing. So what I need to do is I need to tell it to give the first color to both of these, the second color to both of these. The best way to do that is to first simplify this geometry so that in branch 0 you get 2 items, branch 1 you get 2 items, and graft these colors so that in graft and simplify actually. So in branch 0 you get this, branch 1. So it connects it colors these two surfaces of branch 0 to this color of branch 0, and branch 1 to branch 1 to branch 2 to branch 2 and onwards. If you don't get this, which is totally fine because trees are very complex in Grasshopper, or can be, look at the tree video. So you can see that it's colored very nicely, and I'm going to clean some of my geometry up by selecting things and hiding them since they're not actually being used to preview anything. Continue to hide objects. Great. So the floors in the middle, which I assume by what it's showing are the biggest, are the brightest, which is a helpful understanding to have. Now I'm going to do the same thing because this is getting kind of messy and I might not know what's going on. So this got the lowest point for me. This is giving me suction cuts, right? And this is giving me these floors. I can in fact select all of this and make it into a cluster, and I can tell it that it's giving me, it's a floor maker. And this would be incredibly convenient conceptually because I can say, oh, well, I got the lowest point, I'm just making floors. The same goes for here. I have the area, I have, I'm adding the areas together per floor, I'm getting the bounds of each floor's ranges so I can remap it to 0 to 1, so I'm getting a color. So I could say this is actually a process of getting the geometry and offering up a color. I'm going to highlight all of this. And I'm going to say geo to proportional. This is just kind of for my sake because now conceptually I can say, oh, it gets the lowest point, it makes the floors, and it converts the geometry to color proportionally, and then it presents it. And just to follow what we were doing earlier, I'm going to map this onto a model viewport. So great. So now it's only being shown in this one dimension, in this one viewport and not the other ones. And I'm going to remember to grab these clusters and highlight, hide the preview of them. So then now you can see it looks really different. On this side, I'm looking at the interface and the forms that are creating. On the left-hand side, on the right-hand side, I'm looking at the floors and the different areas that are being shown. And then I can also vary the distance between the floors. Now the last thing I might want to do in terms of an interface is this object. This might actually be very crucial to my operation, but it's inside Grasshopper. One thing I can do is I can right-click on it and I can click Publish to Remote Panel. What that does is there's a remote panel. If you go to Grasshopper, go to View, Remote Control Panel. There's a remote panel that actually appears in Rhino. And you notice it's synchronized, so as I move this number changes. And so I can edit the name of this slider. I'll call it floor height because it's the distance between floor. And you'll notice that this number changes immediately also. And I can even slide it to change the value. I can click on this pencil, which will edit the panel. So if I right click on new group, I can say, oh, this is input. And then I could add another group, and I can add a label. And let's say total area. I can say output. And maybe you see where I'm going with this. I have the input and I have the output. I can also move things around to different groups within this input mode. And if I click on the pencil again, I go back to user mode. So let's say I also want to know what the total area of total floor area actually of the building is. So over here I have the floor maker and I have all this geometry and all this trimmed surface. Now I can get area again, and I'll grab the area of all the floors, and then I can do mass addition. This time I'm going to flatten the geometry, flatten the data, so I'm just getting one long list. So by the time I do the mass addition, I'm just getting one single number, which is the total floor area. Depending on the units of whatever is in this world, it might be feet. I have a 75,000 square foot building or a building with 70,000 square feet, which then I can use to calculate the FAR of a site. which is in fact maybe an interesting idea. So I am going to take this value, and I'm going to say, oh, this is the total floor area, and I can right click on it, publish to remote panel, and you can see it's shown up here. Now let's say I want to get the FAR. Now what does that mean? Let's pretend for a moment that the FAR is only proportional to the area of the site that the building touches the ground, which is the lowest most floor. So if we look at go into this geometry to proportional color cluster and make a panel, there's this operation that we did, which is we grabbed the area and then we added it so that we got the geometry per floor. I'm going to do the same thing. I'm going to return to parent, go outside, and I'm going to make another area object, unflatten it. So now, remember we have all these floor areas. Whoops. When I switch this around, the remote panel changes because I've connected this specific panel to the remote panel. So what I want to do is, I don't want to touch this. I want to create another panel. And then I want to do the mass addition process again. So now I have the floor areas per floor. And you'll notice that there's actually some redundancy going on. I'm calculating the area of things twice, I'm adding them together twice, and so it's entirely possible that I can add the added areas up and get the same number and not have to run this twice. And that's something that will maybe speed up the entire Grasshopper script because I'm doing things more efficiently. So because Grasshopper is taking, if you remember the slices we take, we're going from the bottommost point and slicing upwards. So the first item is actually the bottom ground floor. So what I'm going to do is I'm going to say I want to grab an item from a list. I'm going to flatten this list. And then I'm going to get the 0th item, which is the first item, which is 3139. And that's actually perhaps our ground floor area. And I'm going to publish this to the remote panel also. So then if you divide the total floor area by the ground floor area, you get a kind of FAR. It's like FAR for this project. And then I'm going to publish this again. And then since it's nice to remind ourselves what these things are, I'm going to make some labels, move them around, and say ground floor area, and then FAR question mark. So great. So I'm going to minimize Grasshopper, maximize Rhino. Oh, it looks like I still have these points in my drawing, so I'm going to go in and again highlight everything that's not part of a preview object and hide it. So now you can notice that I can start to play around with geometry. And as I move things around, the FAR, the ground floor area, the total area change, which is pretty interesting. And I can do things like grab a lot of objects, rotate them vertically. And each time, new forms are being created. You might say, oh, I can't get a general shape of what the building looks like. So, maybe let's go back in. And this preview object, I believe, was the one that grabs the external kind of form being created. We can check by pressing this and looking around. Yep, it's this one. So then I'm going to re-enable it, and I'm going to make it very transparent, maybe. Perhaps this is pretty good. One thing to note, the one downside to Grasshopper is that if I hide this object, you'll notice that you can see the floor plates. If I show this, even though I have a transparency on, the transparency doesn't oftentimes work that well, even if you go to, say, document quality. So that's just something you have to work around with. So this is great. This is now I'm seeing the coloration of the floors. And actually, what I'm going to do is I will go back in. I'll actually disable this, but I'm going to make the frames of the building darker. So when you move around, you get a heightened sense of the form. And now through this, I can start to play around and deal with different geometry and make new forms, like what is this building, etc. I can do a rough calculation of FAR according to the kind of standard or metric that we've set. I can move things around. I can create new points, that alter the geometry of the building. I mean, this is pretty interesting as it is, and you can imagine kind of move things around. And again, I think this is an interesting place to stop. Again, what have we done? We've created a geometric form, a logic that uses these points. Because I'm using geometry pipeline, I can make new points whenever I wish without going to Grasshopper. I can look around and see, on the one hand, look at a model or look at an interface. On the other hand, on the right-hand side, look at a representation that gives me more data. And it's possible that I can use this to design in a new way. I look at a kind of a brighter floor and say, okay, that's interesting, but that's not what I want because that floor area is limited. I can monitor my constraints on my right hand side and say, okay, well, I'm going to work with my floor height to change the FAR. Let's say it's entirely possible that this is my building and I love this form, but I want to modify the floor heights until the FAR is under 10. So I know that this is what I can get. I could also do this and get certain FARs. And so then immediately there's this negotiation between the constraints of a project or a task and what I can do and what I end up with. You could imagine that another way to design this building would be to design one iteration and work with the FAR and try to kind of have a very slow feedback loop between going back and forth, because this analysis isn't present while you're designing. Yeah, so that's that. Again, if you have any questions or comments, email me, and the skill tree videos on the trees are probably very helpful and will be for a long time in general for all of Grasshopper, because the logic of Grasshopper data is contingent on using trees. So take a look at that. If you have any questions, email me. Thanks.